I would like to take the privilege to invite our keynote speaker, Mr. Yahya T KHEDR. He is 19-year-old Egyptian electronic engineering student. He is also a 3D designer and animator. He is certified SolidWorks expert and he is SolidWorks champion member. He started his animation with public where his animations was hundreds of thousands of views and counting. He also helped us with many blogs. He has written many blogs like for certifications. I will share the link for the same with you all. Now I will hand over to the Yahya KHEDR.
Hey everyone.
Yeah, you are audible.
Okay, great. Now we just have to make me a presenter and I'll start. Perfect.
Yes.
That's great. So, hi guys, I'm Yahya, and welcome to this session with Jordan for SolidWorks user group. This session is called SolidWorks Animations 0 to Hero. So, first of all, let's just talk a little bit about me. So, just as you just heard, I'm a SolidWorks user since 2016. I'm a SolidWorks champion since September 2020, and in March 2021, I became a SolidWorks expert. Okay, so I started using animations a while ago, but in early this year, early in 2021, I started sharing these animations with the public, and since I shared them up till now, they got over 250,000 views on different platforms. That helped me get recognized by Dassault Systems, and some of my animations got featured on the SolidWorks blog and on their social channels. Okay, so you're not here to talk about me, we're here to talk about animations. So this is the agenda of today's session. We're going to talk a little bit about motion studies and the different types of them. Okay, and then we're going to take a couple of types of these motion studies and we're going to go deep into them, like animation and basic motion. And then at the very end, we're going to talk about, okay, we made the animation or the basic motion we made. Now we want to export it to view it to people and different options we have to do so. So first of all, motion studies. Motion studies is like the general term. Okay, so it's like the umbrella where everything else lies underneath it. So first of all, why should we use motion studies? So when you think of it, I can make a model and it looks great and everything, but I want to present it to people. Okay, so the first thing I want is to be eye-catching. Because remember, if I made a post and that post is about something I love, but it's just text, so maybe 10 people will see it. If it's an image, then more people will see it. If it's a video, then it's eye-catching and everyone who passes by it will be intrigued to see it. So for example, can you see this animation? So as you can see, this is something that's eye-catching. It's something that challenges your brain to think of how I made it and such stuff. Okay, if I just showed you something like a still image or something like that, it's not going to be that cool or that eye-catching. So for example, if I showed you something like this, you're going to see that there are lots of details into the model, but it's just a still image. Okay, this model is like it's supposed to be moving, and I can't show you that movement in a still image. But if I made an animation, you're going to be able to see that model in motion. So for example, if you see this animation, as you can see, it's the animation of the very same model. But when you see it in motion, you understand how it works way better. Okay, so the last thing I can think of of why to use motion studies is to see a model from different angles, and that's for a very simple reason. As I said in the second point, seeing something that has movement in a still orientation doesn't give it the whole right to it, right? So the same happens to a model that has lots of aspects and lots of features in it. So if you see something like this, some of you might have known it. It's the Adobe Reader logo, okay? So yeah, I mean, it looks cool and everything, but you can't see any more details unless these captured in this still image. But if I show you an animation of it, you're gonna be able to see all the different views of the model. You're gonna be able to see it from different angles, see what went into modeling such a model, and more details will be present to you when you see an animation as opposed to a still image. Okay, so that's a quick couple of reasons to why to use motion studies. Okay, so now that we've known this, let's go to what types of motion studies are there, because there are different types and each type has its own uses. So right now there are 3 types of motion studies. There are animations, basic motion, and there's motion analysis. So animation and basic motion, they come with every version or every edition of the SolidWorks software, whether it's standard software or the professional software. As for motion analysis, it's only for premium users. So if you've got the premium version of SolidWorks, you're going to have all 3 of them. So right now, let's talk about animation and basic motion, because these are the most simplest, the simplest basic motion and animation are the simplest forms of motion studies. Okay, so when it comes to animation, it's key point based. That means that I make a point in the start of the animation and a point at the end of animation, and I change something in between those 2 points, and the software starts changing the model I made from the first point to the second point, and we're gonna get more into that after a while. But let's just know that that changing in state from the first key point to the second key point is called interpolation. Okay, so when the software changes the model from the first key point to the second one, that's called interpolation. The second form of animation is motor based. So here, instead of changing the model by myself, no, I just add something external to the model, like a motor, and then I define that motor by some parameters like the speed, its orientation, the direction of rotation, and such stuff. And then I let the animation or the software calculate the animation for me. So from these 2 types, you're gonna notice that I provide the software with the inputs, and these inputs I already expect and know what outputs I'm gonna get. So for example, when I define the first key point and the last key point, I already told the software this is the input and this is the output. The same goes with the motors. When I add a motor, I already know that this is the input and the output I expect is defined by the parameters I define. Okay. On the other hand, we've got basic motion, which is physics based. That means that when I make an animation with basic motion, motion is defined by real life phenomena. So in real life, there are things like mass that that have to be taken into account when I make an animation. So for example, a wooden ball won't react like a plastic ball. The other thing is gravity. So there's gravity, of course, in physics. We live in a world where gravity confines us. So we can actually take gravity into account while making basic motion, but that isn't present in animation. And the last thing is contacts and collision. So for example, if I have 2 things moving fast in the same direction, okay, and one of them just collides with the other, I can simulate that in basic motion. Remember the word simulate. That's what physics-based motion is. It's like simulating what real things happen, but inside the software. As for animation, no, I can have intersecting bodies. I can have things that break the rules of physics in animation. Okay, so since I said basic motion is actually something like simulation, that means that it takes tons of computational power to simulate that stuff. But in fact, when you compare it to something like motion analysis, which as I said is for premium users, that is way, way more advanced in computational time and power. That means that if I have something that is very, very detailed, basic motion is going to finish and calculate that animation way shorter in time than in motion analysis. Motion analysis is like real life simulation. Basic motion is like a step down version of it. Okay, so in simulation, we define the inputs and we leave the software calculate the outputs for us. So that's the main difference between animations and basic motion. Okay. So now let's talk about animation. In animation, there are tons of techniques, way more than basic motion, because animation is the first thing the first form of motion studies that comes to mind when you start animating your model. So as you can see, there are three main types, which is by key points, by motors, or using the animation wizard. And we're going to talk about all three of them today. So first of all, key points. So the first thing in key points is that you have to know that I can add as many key points to an animation as I like. So for example, if I have a cube and I want to see that cube from the front, from the top, and from the side, at the start of the animation, I can place a key point and say, at this key point, look at the cube from the front. Then after like 2 seconds, I place another key point and say, here, look at the cube from the top. So the software, when it comes to calculate the interpolation between these two key points, it starts moving the model from the first key point to the second one. And that's like the very basic way of making an animation, you know, like basic dragging. I'm just dragging parts around and placing key points to make an animation. It's not that accurate, but it just gives you a simple output of what you want to see. Okay, the better version is to do it using mates. So for example, if you look at this, this is a model that I've made an animation for a while ago. Some of you might have seen it before. So let me just play the animation real quick for you. Okay, so this is an animation for a bar of chocolate that is like making a neat trick, like as if it's getting shorter and shorter, and you're gaining in impossible parts of the bar chocolate. So for this animation, I can of course just drag parts around and make key points. As you can see, these blue dots are the key points. But instead, I use mates. So if I expand the mates over here, you're gonna see that I've got a couple of mates, like this limit distance mate and this other limit distance mate. And all I'm doing is that I go to the very first part over here at the very first second of my animation, and I say, let the distance be, as you can see, 32 millimeters. And then I come after 1 second and say, let the distance increase to 92 millimeters. So as you can see, at the very first part of the animation, everything is normal. And after 1 second, that distance is taken into account because I changed it using a mate. So what I did is that I drive my animation using a mate. The same thing goes for this limit distance. So here it was 0 millimeters, and over here it's 40. So if I move another, as you can see, this big chunk moved this direction 40 millimeters. Okay, so by adding different points, so for example, if I just drag this over here and drag this over here and come at the very beginning and say calculate, you're gonna notice that I've just changed something in my animation and it's gonna calculate it. And based on these points that I made, these key points, if I played it once more, you're gonna see that it changed what was happening. The animation is changed based on these key points. Okay. So these are the very basic types of key points. But what if I not just only want to change the movement of my animation, I also want to change how I see the animation. So over here, we're gonna use camera movement. And camera movement is the very same thing. So instead of adding key points for changing the orientation of the animation, I'm gonna start changing how I look on the animation. So as you can see in this animation, the model itself is still where it is, but the camera that I added where I see the model is changing from left to right. Okay. So this is what allows me, also using key points, to change the way I look at an animation. So all I did is just add a key point at the very start of the animation, and at that key point, I say, let the camera be at this position. And at the end of the animation, I add another key point and tell it to make the camera at another position. And all the software does, it's making interpolation between those two key points, and it just starts moving the camera. Okay, the last thing I'm going to say in key points is appearances. So for example, if I have a model that's colored red, and I like the animation to be that model changing from red to blue at the very end of the animation, I can do that also in SolidWorks. So this is an example. Pay close attention to the red parts at the very top of the model. You're going to see that the model is actually changing its transparency. So what I did is that I placed multiple key points in my animation, and at every key point, I changed the state of these components. So for example, I can change the color, I can change the display state, I can change the transparency. Anything is possible in SolidWorks animations while I'm using key points. Okay. So that's about key points. Now let's talk about motors. Okay, so if I'm having like an axis of a motor and I want to rotate it, or if I'm making a car and I want to rotate the wheel, okay, I can make it using key points. I can like add a limit angle mate that goes from 0 to 360, and I'm just gonna add a couple of key points every now and then, changing the value of that angle from 0 to 360, and so on and so on and so on. But that's a tedious process. It takes tons of time from me and tons of effort from the software to calculate it. There's an easier way to add a motor. So actually, SolidWorks animations includes two types of motors. There are linear motors or actuators, and there are rotary motions. So as I said, all we do is just add the motor, select the axis it's going to rotate about, and select its speed or its drive curve. Just select, define all the parameters it needs to move. So for example, this animation was actually made using one rotary motor. So coming to think of it, all I did is just add a rotary motor to that cyan or light blue piece in the very middle. So that part's gonna rotate around itself. As you can see, that top plane of it is rotating to show how it's rotating. And all I did is just add a coincident relationship between that red part and the plane of the rotating X. So as the yellow part moving, the chain is moving, it's moved because it's driven by the yellow, by the cyan part in the middle. So this blue part rotates, it drives this red part drives the whole chain to move around and around. Okay, so that's about motors. So the last thing is Animation Wizard, and this is like a big topic because Animation Wizard is a very dense feature, and I'm going to talk about a couple of points on it. So first of all, we've got rotation. So you can make a rotation of the model using Animation Wizard, and I'm pretty sure most of you will be familiar with it. But in my opinion, I think that it just sucks. To be honest, I think that rotation in the Animation Wizard isn't cool. You want to know why? Let's look at it. So as you can see, this is a rotation made by the Animation Wizard in SolidWorks. But if you pay close attention, you're gonna find that the model isn't actually rotating around its own axis. It's actually rotating about the screen axis, as if it's off-axis rotation. I sometimes see the model from the top, I sometimes see it from the bottom. So if I open the CAD model, this is the CAD model of the animation, and here is the screen axis rotation version of the model. And as you can see, there are multiple key points over here. So let's make it ourselves. Let's start a new motion study. And if I go over here to Animation Wizard, you're gonna see the option to rotate the model. I'm gonna say next. I can now define the axis of rotation. Let's go with the y-axis counterclockwise, and let's say only one rotation is enough. Next. Here I say I wanted to start at this second, so I wanted to start at the very beginning, and the duration of the rotation, let's say 5 seconds. Finish. As you can see, all it did is just added a couple of key points over here. So this key point is like this key point is over here, and so on and so on. And all the software does is that it's making interpolation between all these key points. So if I play the animation, as you can see, it's going to go through all these key points. And I want you to pay close attention to these 3 arrows, these 3 axes over here. These 3. Okay, so I'm gonna play the animation. Notice that I defined it to rotate around the y-axis, but even the y-axis isn't rotating perfectly. As I said, it doesn't rotate around the axis of the model, it's rotating around the axis of the screen. So what about a better version? Okay, if I wanted to make it to rotate in a perfect way, like a re-rotation around the real axis of the model. So I can make something like this. As you can see, it's rotating around the model axis of the model, which is the y-axis in the very center of the model itself, not the screen, which is like way more practical, and it just makes more sense when you come to think of it. Okay, so let's see how I made this. So here's my model, and as you can see, if I zoom out a bit, I made a sketch, okay? A sketch of a circle. That circle is a bit on top of the model, like that. And I'm gonna use that circle to add a camera. So if I came over here to appearances and added a camera, you're gonna see that I already have a camera over here. All I did, let's just add a new camera for now. As you can see, the view on the right is what the camera is going to see, and the view on the left is the model itself. So you're going to notice there are 3 topics over here, or 3 main points. There's this yellow point, which is the position of the camera itself. And there's this red point, which is the position of where the camera looks at. Okay, so for now, let's define this as the origin of the model. Okay, and as for the camera position, I can define it anywhere, but I prefer to define it using this circle I just added. Okay, if I'm going to show the numeric controls to have more control over my model, and let's say I just want to raise this by this amount, and just like that, you're going to notice that I have a clear view of my model, and the camera is always looking at that red point, and it's placed on that yellow, on that blue circle. So if I want to change the view, all I do is just change this value from 0 to 100, where it just rotates around my model. Okay, so now if I put it at 0 and say OK, as you can see, it's perfect. All I'm going to do is now just start a new motion study and then drag it a couple of seconds, like for 5 seconds. And over here, I'm going to go and add a new camera key point. So this is the camera. I'm going to go over here and place key. So as you can see, I've got a key. If I double click on it, I get to edit that key. And all I'm going to do is just drag that from 0 all the way to 100. If I click OK and play the animation, as you can see, I've got a real animation rotating about the y-axis. And if you look at the triad over here once again, you're going to notice that the y-axis is really what I'm rotating about. So look at this. The y-axis is constant, and the x and z axes are rotating about it. So now I'm sure that I've got a real animation of the model rotating around the model axis. Okay, just a quick tip. If you, for example, let's just delete this quick. Okay. So, for example, right now I'm in this camera view, but if I'm out of the camera view, something like this, and I started the motion study, you're gonna notice that if I came over here and added the camera, you're gonna notice that I don't have that blue bar that was present before. Why is that? Because the very first frame in the animation is like this, not the camera view. So what you want to do is turn on the camera view from over here, choose the camera, and then you're gonna come over here to orientation and camera view, right click and say replace key. As you can see, now the animation is perfect. What that does is it replaces the very first key from the previous view to the new view, which is the camera view. Okay. So now that we've made a perfect rotation using Animation Wizard, let's just catch up a couple of points. So it's still possible to make a perfect rotation using the Animation Wizard, but it's just going to be tedious. So for example, if I open that model once again, you're going to notice that these key points are not just present over there. No, I can actually edit them. So editing them is what's going to allow me to change what I want. So for example, I can delete this key point. I can move this key point over here. I can just drag this over here, drag this here. And if I play, it's going to react to what I've just changed in the key point animation. So I can still change some stuff about the animation, but I don't have maximum control, and it's just going to take more and more steps from me as opposed to when I'm using cameras, when I have full control in a couple of steps. Okay, so that's about animation. Now let's see exploded views. So if I come over here to an exploded view, this is an animation I made using the Animation Wizard and by adding an exploded view of my model. So this is a puzzle. It's called the Komiki puzzle. Okay, it's a wooden puzzle. I think it's Japanese, but I'm not sure. And this is just an animation of the model being exploded and collapsed a couple of times. Okay, so just to show how this model is being played and such stuff. So I just made this animation, and as you can see, this was made using the Animation Wizard. So what that means is that instead of going by myself and adding a couple of key points every now and then, or adding a couple of key points for mates if I'm going to use mates, exploded views are way easier to make, and importing them to the Animation Wizard eases a lot of time and saves us a lot of time. Okay, now let's get into make controllers. So if you don't know what make controllers are, it's okay, because they are relatively new. They were introduced in 2016. Okay, what they do is, from their name, they control mates, and that means that it's gonna make a key point animation for me using mates, but instead of me doing it by myself one by one, it's just gonna be like a thorough way to make it all at the same time. So it's just way more accurate than just dragging key points by my hand, because I can have numerical inputs, and it's also editable. So when I make the mate controller, I can import it into my animation and change it later on if I want to. So let's just see an animation I made using mate controller. As you can see, this is an animation of a bench where it's got a couple of parts, and these parts can go down and up as I want to change the shape of the bench. Okay, so what I made over here is that I've got a couple of limit angle mates that are required to move every part of these 16 parts. Okay, if I'm going to use a key point animation using mates to make this animation, it's going to be taking ages for me, especially that last one when I'm making like a wave. Okay, but if I go to the CAD file, you're going to notice that it's just way simpler and way easier than what you might think. So here's my part. Okay, and as you can see, if I scroll down here, I've got a mate controller. So let's just make a new one with ourselves. So if you go to insert, you're going to find it at the very top over here, mate controller. Now this is the mate controller property manager. Over here, I'm going to select the mates I want. But there's a very neat feature, which is this. It's collect all supported mates. As soon as I click on it, this mate controller is going to scan all the mates I have for mates that it supports. And I'm going to talk about which mate it supports in a while. Okay, if it finds any mate that it can use, it's just going to get it in here. If there's one I don't want, I can just click delete. Okay, if there's one I just don't want to use. After that, all I have to do is come over here and add positions. So this is how I interact with my mates. So at the very first position, everything is set to 90 degrees, for example. If I just come over here and add a new position, let's say call it position 2, I can now start changing the values of these different mates at the very same time. So all of them at the very same time, and not just by dragging, I can also enter values. So for over here, I can say 60 degrees and so on. Let's just change this, this, and this. Of course, I'm just messing around right now. Okay, now I can click update. And for example, if I wanted to go back again to the very first position, notice that if I just click add position, it's going to duplicate the current position. So if I want all of these just to go back again, all I have to do is get the very first position, duplicate it, just like that. But there's a small issue. So here it is, the first position, the second position, and the third position, it goes back again. But there's something I'm missing. You know what it is? It's time. So, okay, you want me to turn off my webcam just a sec. I think that's better. The internet connection looks like it's a bit breaking down. If I come over here, you're gonna notice that I can actually change the time. Okay, so I can say, let's say the second position takes 5 seconds to be made, and it returns in only 3 seconds. So if I wanted to return a bit fast, you're gonna see that the total duration over here is 8 seconds. Okay, I can say okay, and now it's saved down here. A quick thing also is that I can click on it and I can change the position without even editing it. So as you can see, I just set it to the second position, or I can set it to the very first position too. But that's not what we're here for. We're here to make a motion study. And from over here, all I'm going to do is I'm going to go to the animation wizard. We talked about the rotation. We talked about exploding and collapsing. Now let's talk about mate controller. Next. So now, since I have multiple mate controllers, I'm going to choose the mate controller I have. I'm going to make this one. And these are the mates it's going to use. And as you can see, I can import it as key points or as motors, but as you can see, it's saying it's recommended for motion analysis. So right now we're going to use key points. I'm going to say next. It's going to start at the very beginning, and the duration is grayed out because it takes the 8 seconds from my mate controller and puts them over here. So it overrides the value in here. I'm going to click finish. And just like that, you're going to see if I scroll down here and open the mates folder, that it's already made all these key points for me without me even having to open the animation. So if I click play, it's going to animate the changing in the different values of these mates at the same time. Okay, so as you can see, I just made like half a dozen key points without even requiring me to start even an motion study. And I can also drag these around. So as I said, it's completely editable. I can drag these around and I can change the state of everything I want. So if I get over here and change it like this and play, it's still doable. As you can see, the model reacted to the changes I've made, and now the animation is different. Okay. So this is what mate controllers can be used in Animation Wizard. So when it comes to the types of mates that it supports a couple of mates. First of all, angle mates and limit angle mates, like the ones that you just saw me using. These were limit angle mates. The second type is distance mates and limit distance mates. And these are the ones I used in the very first animation of the chocolate bar. I used limit distance mates and changed the values from one value to another. We also have width mates. And in the width mate, I can add it to a mate controller in 2 options, using the dimension option or the percent option, where I can define it like move to 25% or remove 2 millimeters, for example. So I can define it using dimensions or percent. I can also use the slot mate and the path mate, and in both of them, I can also use the distance parameters or the percent parameters. Okay. So now that we've talked about animations, let's talk about basic motion. So in basic motion, there are multiple techniques, but we're just going to talk about 3 of them right now. So first of all, there's gravity. And as I said, basic motion is like an extension to real physics being simulated inside of SolidWorks. So if I go to gravity, you're going to see that it simulates acceleration of loose parts. Remember the word loose parts. Why? Because I can still use mates inside basic motion and define a part to be hanging in the air. So for example, if I have a part, let's say a ball, I model a ball and I model a surface of a ground, and that ball is hanging in the air, and I make an animation, that ball is going to defy physics and it's going to hang in mid-air, even though the reality is that that ball should fall down. So in basic motion, we can actually simulate that, or we can add gravity. Okay, so for example, let's see this quick animation. You're gonna notice that I've got a couple of balls that are falling down. Okay, and due to gravity, they can keep falling down, and when there's a hole at the very end of the loop, they keep falling down once more. Okay, so if I was making this animation using the animation type of motion studies, these balls will just hang in midair and they won't fall down. Okay, so let's just see what I made, and remember one quick thing: keep an eye on the direction of the gravity. Okay, because that's going to be a very important part we're going to talk about right now. So as you can see, here's my model. Okay, and if I go to motion study, you're going to notice that I've got a rotary motor to rotate this light gray disc, and I also have gravity. Okay, so if I just edit this gravity feature, you're going to notice that I have gravity parameters like its direction and its value. So the default value is the gravity of Earth. So it's 9.8 meters per second square. But I can also change it to any value I want. Let's say I want to simulate the gravity of the Moon or Mars or Jupiter, or any arbitrary value I want to add. It's okay. But this is the thing I was talking about, the gravity parameters when I add the direction. So as you can see right now, if you look at over here, you're going to notice a green arrow pointing downwards. Okay, that green arrow is the direction of the gravity. So if I just go over here and change the direction, flip the direction, you're going to notice that that green arrow at the very right is actually pointing upwards. So I just flip the direction of the gravity, as if things will fall upwards, not downwards. I can also set it to the Z direction, so it goes this way, or the X direction, or any value. For example, if I want the direction to be according to that edge of the model, as you can see, the arrow is now pointing in an arbitrary value, an arbitrary direction, and I can just change the direction like this direction, and I can also add an arbitrary value like this. Okay, and I can say okay, and that is the new value of my gravity. So this allows me to simulate real life things in my animation. Okay, but as you can see, let's say I here have a rotary motor. If I add another rotary motor, let's say over here, you're gonna notice that it's called rotary motor 2, and this is called rotary motor 3. The same goes for contact, for example, which we're going to talk about in a second. But when it comes to gravity, there is no number. So for example, this gravity, as I said, it goes in this direction. Let's go and add another one. Okay, so here it is. This is the gravity button. I'm going to click on it. And now, as you can see, it just edits the previous one. Okay, for example, let's change this to a Z direction and put another value and say okay. It doesn't add another one. All it does is it just changes the value of the present gravity in the basic motion study. Why is that? Because in real life, there is no such thing as two gravities at the very same time. You either have one or two. So what happens right now is that this is the exact same thing as if it was happening in real life. You only have one gravity and it's going in any direction you want, but it's only one. So that's the thing I was talking about, where you have to keep an eye on that direction and remember that there's only one gravity simulation element per assembly. You can't add multiple ones. Okay. The last thing I just want to mention is that if you have like a linear motor moving a ball to the left, and the gravity is actually pulling the ball to the right. In SolidWorks, motion based on motors actually overrides motion that's based on gravity. Okay, so just keep that in mind. If you have like gravity pulling a ball down and for some reason you find it moving upwards, that's probably because you have a motor that's moving it in the other direction. Okay, so the second two points are springs and contacts. So just due to the time, we'll not be able to cover both of them. So we're just going to jump into contact, but just to know, springs can be made into basic motion. And I'm not just talking about modeling a spring or animating a spring as if it's compressing and decompressing. No, I'm talking about real physics, like a spring or a damper in a model, like a suspension kit, for example, where it simulates real spring motion. Okay. Now let's get into contact. So as I said before, in an animation, I can have two parts that are intersecting with each other. But in real life, that's impossible. Two bodies can't occupy the same space. There have to be contact between them, and that contact is going to repel them apart as soon as they touch each other. Okay, so that's what we're going to simulate right now in basic motion. So this is a quick preview of what I'm talking about. As you can see, this was made using animation. Okay, just a couple of mates and animation. Let me play it once again. And we're trying to replicate this using basic motion. Okay, so let's dive deep into it right now. So this is a CAD file that I used. Okay, and this is the motion study that I made at the very beginning. So this, as you can see, is an animation. All I did is just add a rotary motor over here to this axis where it's going to rotate it. And if I go down to the mates, you're going to notice that I've got a couple of tangent mates between these these blue discs and these white rods, where that tangent mate, or I can also use a slot mate if you want. Okay, sorry, a cam mate. When I rotate the axe using the motor, these rods will go up and down according to the tangency between them. So what if I want to do this, but in real life, using real life physics? So let me just get out and start a new motion study. And this time, let's change this from animation to basic motion. Notice that since I'm wanting to use contact, if I just add contact right now, here it is, I'm gonna get an error. As you can see, it says the tool that you've chosen requires the use of basic motion or motion analysis. So I have to change it. Okay, so I'm just gonna change it to basic motion. And as you can see, there's contact type, and it here says solid bodies. Why is that there only one option, but it still requires being said? That's because there are actually two options. The other option is between curves, but that option is only present in motion analysis. So over here in basic motion, we only have one option, which is that. Okay, so here we're gonna add the selections. So what we want the contact to be between is all these white axes and these discs. So let me just select them real quick. And I'm gonna say okay. So now that I have my selections perfect, let me just suppress the tangent mates because I don't need these anymore. As I said, all I'm going to do is real life simulation, real physics simulation. So the contact is going to do everything for me. I also want to add the motor. So here it is. Let's say, for example, that I wanted to go 30 RPM. I think that's going to be a good value. And as for the motor direction, let me just zoom in over here and select that. Okay. And now all I have to do is just play the animation. And as you can see, while the axe rotates, the circles rotate with it, and the vertical rods move up and down according to, oh my god, what's happening over here? As you can see, these rods are actually moving upwards and upwards and upwards, and there's nothing to stop them from coming down back again. And that's the third thing we talked about a couple of minutes ago, which we have to add. So not only a rotary motor and some contacts, but we also have to add gravity, because when parts go up, they have to go back once again. So here I am adding gravity to the y-axis. The direction is down, I'm sure, and the value is perfect. Click OK, and now let's calculate. So as you can see, it's taking quite a while because this is real-life simulation, of course, but at the very end, we get very similar results to the ones we just saw using real mates. Okay, so I'm going to play it once again. As you can see, it works perfectly, but it calculates in a very long time, and I just don't like that. So if there are anything that we can do to reduce the number of mates or reduce the time, reduce the contact, reduce anything to make the time of calculation a bit less. So if you saw over here in the solid body contact, let me just drag this to the very beginning and edit this. You're gonna notice that there's an option called use contact groups. And what that means is that if I have a contact group, it doesn't simulate the simulation or the collision between the different parts inside the same contact group. So if I just deleted all of these, clear selections, and I said use contact groups, you're going to notice that I've got two groups right now. And if I add, for example, a couple of things in the first group and a couple of things in the second group, SolidWorks won't actually simulate the collision between the things in the first group together or the things in the second group together. It's only going to simulate the things between the first group and the second group. So in this animation, for example, the blue discs, I've got a problem with colors today, I don't know why. So the blue discs actually don't collide with each other, nor do the vertical white rods. So I don't need to calculate for every frame in the animation the collisions between these two. So what I'm going to do is I'm going to go to the first contact group and I'm going to select all the circles. I just select them from the very beginning, like that. And in the second contact group, I'm going to select all the rods. Here it is. I'm going to click OK. I'm going to click Calculate. And you'll notice that it's calculating it way faster than before. That's because it just doesn't require it to calculate tons and tons of unnecessary collisions that may happen. So as you can see, it's over. Now let's play the animation. And it gives us the exact same results, but in a shorter amount of time. Okay, so as you can see, contact groups actually reduce the solving time because it reduces the part it has to simulate the collisions between. Okay, and this is the preview of the animation in full screen that was made using basic motion, just to compare it with the one you saw at the very beginning. So this was made with basic motion, and as you can see, it just gives us similar results to what we saw using animation methods. So now we've made our animation and it looks cool and everything. Now we want to export it as a video, as I've been showing you all throughout this presentation. I want to export the animation as a video to show it to people, because honestly speaking, if I have a cool animation, but I just to show it to someone, all I have to do is install SolidWorks and open the file and show it to them. That just takes a lot of time and a lot of effort, and it's expensive, and it's just ridiculous. Okay, so what I want to do is export the animation into a file that anyone can see, like a video file. And this is actually possible in SolidWorks, and there are tons of options to export, and these options actually change dramatically the output version of your animation. And we're going to talk about these right now. So first of all, we have to know that if I'm exporting an animation, the animation, if it has assembly features like cut extrudes or any types of assembly features that are only added into the assembly, not the part itself, or if it also has in-context references. So for example, if I have a model and there are relations between that model and an external model, these things can actually change the model's geometry, and we're going to see that in this animation. So if you look over here, you're going to notice that I've got this part. This is actually a something that looks like a ball and ratchet, but it's just like a rotary one, and the model itself is changing. Okay, so that means that the software has to rebuild the whole assembly on every single frame. Okay, so let's just see how I made that in SolidWorks. So here's the model. Okay, and if I open the motion study, as you can see, it's on animation. The type is animation, and I can play. And as you can see, these blue bars over here, these three ones, are actually changing their dimensions and changing their shape throughout the animation. So just to see how I made that, if I come over here in the model, you're gonna notice that I have this arrow over here at the pole. Okay, you can see this arrow. So this arrow means that there are external relations. So that pole is just not fully defined on its own, but it has relations that are outside of the same part file to define it. And if I open the file, you're going to notice that this sketch, which is sketch 3, it has an arrow on it, and that's the thing that's causing the external relation. So just to know how I made this, for example, you see this ratchet. Okay, so this ratchet, I wanted to push against this arm of the pole. So all I did is that, let's just open the pole file real quick. All I do is this. Let's just roll back. I have my basic extrusion, and then I have this sketch, which if we look at it, it just aligns with a point in the very center. Okay, and that point is extremely useful, and you're going to see why right now. So if I go to the second feature, I just extrude this, but let's just change the color of this real quick, of sketch 3. Let's make it red, for example, and let's show it. So you're going to notice that it actually extrudes all the way to that sketch I made. So if that sketch, for example, changed its position, if that sketch actually moved, so this arm will actually move too. So that's the base of my animation. That's what I made. Let me just close this. All I do is that I get that red line, and I get it from that ratchet. So with the intersection between that blue part and that gray part, that intersection is a line, and that line is what I imported into that pole file so that it can drive the arm to move up and down. So now let's just take a quick look at the ratchet file. Okay, if you're gonna notice something, notice this. if I click on this part, it just selects the whole side faces of the model, as if it's all one single face. And that is the key to my animation. So if I just edit this part, let me edit the sketch, you're going to notice that I have one big sketch, which is this. As you can see, it's a spline. Okay, so that spline is actually what drives my outer shape of the part. So what it does is that if I have multiple faces, like a curve and then a line and an arc and a line and an arc and a line, when the ratchet rotates, the face ends, and that intersection between the ratchet and the pole will end too, and it's going to give me an error like after half a second or something. But to make this consistent all the way around the ratchet and the pole, what I have to do is have one continuous face all around the ratchet. So to do that, all I did was just model make my sketch as ordinary, and then I selected it all. And there's a feature over here, actually, you can search it in the commands. Okay, it's called fit spline. Okay, so what that does is that it makes a spline from the selections you made, and that's what I made. So that big spline is actually some arcs and lines that I made, and then I converted them to this one outer shape. When I extrude that shape, I get this model where I have only one outer face. Okay. So the last thing I have to do is just make the intersection between the two of them. So if any of you have any idea what feature I can use to make an intersection between the pole and the ratchet, I'd love to hear it. And while you type it in chat or tell it to each other, I'm going to make it right in front of you. So I'm going to edit the pole. Okay. Let me just drag this all the way over here, so as if I still haven't made anything. And on the front plane, I'm going to make a sketch. As you can see, I'm actually working in the pole inside the assembly environment. And all I'm going to do is I'm just going to select this, and I'm going to use a feature called intersection curve. What intersection curve does is that it gets the intersection between the plane or the face I'm sketching on and the selection I just made. And as you can see, this front plane, it cuts this part in two places, over here and over here. So now I have these two black lines. I'm going to just delete this one because I don't need it right now. I just need that one. And if I go exit sketch, you're going to notice that that sketch 4 that I've just made, let me just change that one's color too. Get out of edit component. Let me change the color to something like red. Okay, so with that line, it also has an arrow on it, and that's because it's also defined in the part and outside of the part. So when I rotate that ratchet like this and make a rebuild, you'll notice that that line actually changes its position. If I rotate it a bit more and Control Q for force rebuild, the line changes its position. So if I now make something in the model that depends on that line, it's going to change its position too. And that is the base of what I just made. So let me just go over here and click reload to drive this to the very initial position. So this is what the animation was like. And now if I click play, let me just loop this. As you can see, the model is changing based on the rotation of the single motor that I added to this animation, which is based on that ratchet. As the ratchet moves, the pole rebuilds on every frame and gives us that cool animation. Okay. So as I said, the whole assembly is rebuilt on every frame, and using animation motion studies, I can actually change the shape or the geometry of my models throughout my animation. But this is only possible in animation motion studies. So if I made a basic motion, I can't do that. And not all animation motion studies actually have this. So if I make an animation, but it's processed with accelerated rendered animation, which is an option in the export options, or if I render it with PhotoView 360, which is a built-in add-on for SolidWorks that renders the models like a step-down version from SolidWorks Visualize, or if I even export it as LXO files or Luxology scenes, okay, anything of these three will actually maintain the original geometry. So if I have a model that's changing throughout the animation, but I saved or exported the animation using PhotoView 360, I actually get a still shape of the model. It doesn't rebuild on every frame. Okay. So now that we've known this about animations, let's get into real exporting. So when it comes to animations, since these are the things that I make in SolidWorks, if I have a motion study in general, I can save it as a video file, as I said, like the ones I just show you, a series of still images, which is a series of frames, for example. So if I have an animation that's 1 second and it's 30 frames per second, I can actually save it in two ways. Either as a 1 second video that's 30 frames per second, or I can actually export it as 30 images like PNG or JPEG or anything, 30 images that if I play them very fast, I'm gonna get my animation. The last thing is Luxology scenes, which is LXO files. These are things that are used when you render the model, okay? The last thing I just want to say about exporting over here is that exporting might take somewhere from a couple of seconds to a couple of minutes. It might even take a couple of hours. And that depends on two things. One, resolution, and two, the FPS, or the frames per second. That means that if I'm making an animation that's, for example, 720 by 720, like it's a square animation, it's 720 pixels by 720 pixels, is going to be way faster than if I make it, for example, 3000 pixels by 3000 pixels. It's going to take way longer because I increased the resolution. The same goes for frames per second. If I make an animation that's like 30 frames per second, it only has to rebuild itself 30 times in a second. But if I make it like 60 frames per second, it's going to take way longer to export. Okay. Now, what differs between these two is that you have to have the ability to define these parameters according to your needs. So for example, if I'm uploading a video to YouTube, I need it to be in high resolution and high frames per second. If I'm just going to use it in a presentation, okay, I know that it's going to be presented using a data show, for example. Okay, so that means slideshows in general, they reduce the quality and the frames per second of my animation. So if I make it like, for example, 60 frames per second, it might only be presented in 15. So there is no actually real necessity to make it in 60 frames per second. The same is with resolution. If I'm going to play it on a very big screen, then I will have to make it with a very high resolution. If I'm just going to play on my mobile phone, I can reduce the resolution as I want. Okay, so how to choose the perfect resolution and FPS is according to your own needs. You should be able to define them as you're the one who knows how you're going to use your animations. So the last thing I'm going to talk about in exporting options is video compression. And video compression means compressing the data inside your file so that it reduces the file size and therefore it changes the exporting time. So for example, if I have an animation that is for 50 seconds, okay, it might take, let's say, 50 megabytes of storage. If I compress it, it's going to take a couple of more time to export, because it's of course going to compress the file for me, but the file at the very end will be something like 20 megabytes per second. So it changes, Okay, and compression is actually a very good thing, but it can also be a very bad thing if you don't know how to use it wisely. So, for example, you've got three images over here. The uncompressed file in the AVI file format, there's the fully compressed file in the AVI file format, and there's the MP4 file. And MP4s actually don't have video compression, it's only in AVI right now in SolidWorks. Okay, so in AVI, you have the option to choose the video compression as you like, and I'm going to show it to you in a second. But in MP4s, it's already well balanced between the file quality and the file size. Okay, so let's check this out. I'm going to open the file. This is the file of my animation. And if I open my motion study, okay, and if I play it for you, this is the my animation. Okay. Now here is the save animation button. Okay, so all I'm gonna do is just click save animation, and from here I can choose the file name. Test, for example, save as type. As I said, these first four ones are video files, so AVI, FLV, MKV, or MP4, and the rest are image files, so series of bitmaps or series of JPEGs, PNGs, TGA, or TIF. Anything of these ones at the very bottom, these are series of frames, but the first four are a video file. Okay, so for example, if I choose AVI, and as you can see over here, I can choose the resolution, which is the aspect ratio and the image size. So for example, over here, I can say I want it to be fixed aspect ratio as the camera, since I'm actually using a camera over here. So that means that the camera is 2:1, for example. So if I say here 1,000, it's going to be 500. Okay, if I say here, let's say like this, over there it's going to be the exact half of it. If I turn off the fixed aspect ratio, I can actually make it anything I want. So for example, if I wanted to make it fully HD, as you can see in the background, it changes. Okay, I can make it, for example, 120 like this, and 720 like that. That's HD, and as you can see, it's also changing in the background. But for right now, let's just use the camera aspect ratio, and let's say I want to make it like that. Let's say full HD, because I want high quality and I know that it's going to be presented on a big screen. Now I can choose the frames per second. The default is 7.5 for some reason, which is pretty low, but I can make it like 30, for example, or 60. The last thing is that I can actually change what I want to export. So the entire animation means that from 0 to 6.1 seconds, it's going to export it all. I can choose time range, which is like from 2 seconds to the end, or from 1 second to the end, as I want, or not even from the end. So from 2 seconds to 2.5 seconds. So it's just going to export half a second, for example. Or I can actually export a single frame. So I want this frame or that frame, the frame at the 3 second mark, anything I want. But for now, let's go with the entire animation. Okay. As you can see, there's another option here, but I didn't talk about before. It's renderer, and right now it's SolidWorks screen. That's because I don't have a Photo View 360 add-on. But if I had it and I added it in SolidWorks, I actually have a drop-down menu just like this one, choosing between SolidWorks screen and Photo View 360. Okay, so right now let's go with SolidWorks, and as you can see, I'm choosing the AVI file. I'm going to press save, and this is what I'm talking about, the video compression. So the compressor, it changes according to your software or your device, the compressors you have installed on your device. Microsoft Windows video is like the default. You've got full frames uncompressed, which is one of the 3 options I showed you in the slideshow. So what it does over here, it just makes no compression whatsoever. Full frames, full size, full everything. Or I can actually say, no, I want the compression to be like very high, 100. This means like no compression, or very low. This is the lowest thing, which means a very high compression and very small file sizes. Okay, usually we make it something in between, because we want to have high quality, but at the same time we want to have small file sizes. Okay, as soon as I click OK, it's going to render the animation for me, export it, and so on. But I already have it, so I'm just going to click cancel. But what I want to show you is that if I make it, for example, as MP4, okay, let's just leave these as they are. If I click save, it just gets into saving the animation for me. It doesn't require any compression for me. Let's just stop it for now. Okay, so let me just close this for now. Now let's see the different options in rendering my animation. So this is the uncompressed AVI, and it's 4 seconds long. And if you look at the file size, it's 292 megabytes. That's way more than quarter a gigabyte. That's tons of storage for a 4-second animation. But if we look at it, you're going to notice that it's actually quite high in quality. So here it is. As you can see, it's high quality, high FPS, high resolution, high everything. Okay, but does that still mean that 300 megabytes of storage for 4 seconds, is that sensible? I mean, some might allow it, but for me, it's just way too much. So let's say I want to compress the file. So let's try the fully compressed AVI. So I drag the slider to the very left, so it's compression is 0, and the same 4 seconds is now 1.57 megabytes. It's like less than 2 megabytes. It's really small, but on the other hand, look at the quality. Oh my god. So as you can see, low FPS, low resolution, it's pixelated. There are issues in pixels everywhere. I mean, it's doable, but it's just bad. Okay. The last thing is an MP4 file, and as you can see, it's also 4 seconds long, but it's 23 kilobytes. I mean, like kilobyte. We're not even talking about megabytes anymore. We're talking about kilobytes. It's very, very, very small. Okay, what do you guys think the quality will be in this one? Okay, I'm just gonna give you a couple of seconds to think of it. So the 300 megabyte was very high quality. The 1.5 megabyte was very low quality. What do you think will happen when I play the 23 kilobyte version? Without further ado, here it is. Look at that. It's just perfect. It's the perfect balance between file size and quality. So I have very small quality. No, I have extremely beautiful quality, and at the very same time, I have extremely small file size. It's perfect. Okay, but as I say, it's at the very end, it's up to you to decide which one of these three you're gonna need. Okay, it depends, as I said, on your needs and where you're gonna use it and how you're gonna use it. So for example, if you're not gonna send it to someone, you can use something that's uncompressed if you want. But if you're gonna send it for someone, it's gonna be a bit harder and taking tons of time to send a 300 megabyte video as opposed to sending a 23 kilobyte video. Okay, and that's all for today. Time for a Q&A. So if you have any questions right now, I'm open for questions. You can send them in the chat, or if you're able to open microphones. I'm not sure if anyone virtually attending wants to ask questions. You can also send them in the chat. And if for any reason you don't have the ability to send me the question right now, or if you have any future questions later on, all you have to do is just scan that QR code, and it's going to take me to my you to my LinkedIn page, where you can send me a message at any time, and as soon as possible, I'm going to respond to you. Okay. I hope the session was a good one, and I'm just waiting for your questions right now.
So basically, I have one question. Am I audible?
Yeah, sure. Yeah, go ahead.
Okay, so I want to ask, like, we have used the mate controller. So basically, we can ask mate controller for limit angle mate and limit distance mate, right?
Yeah, that's right.
Okay, so that's all. Anyone have other questions? Okay, so we can go for the question answer session, like quiz session.
Okay, that's great. Let me just turn off my screen right now. And I'll just come up with the questions. So these are 5 quick questions. They're not very hard. They're just to see how well you listen to the presentation and such stuff. Okay. So I believe most of you will be able to solve them. Okay. So the first question is, how many types of motion studies come with the professional license of SolidWorks? I'm going to say the question again. How many types of motion studies come with the professional license of SolidWorks?
Okay, so basically the question is that how many types of motions comes with the professional license that we discussed earlier. Okay, 3. Okay, is it correct? Someone is answering.
I'm sorry, I didn't hear the question. 3? No, that's unfortunately a wrong answer. It's not 3.
Okay. Who is saying? Okay, someone is saying 2.
Actually, 2 is the correct answer. Yes. So as I said at the very beginning of my presentation, there are 2 types that come with every license of SolidWorks: the animation and the basic motion. They come for the standard and for the professional license. The premium license gets a 3rd one, which is motion analysis. Okay. So now let's go with the second question. The second question is, how many mechanical mates do mate controllers support? Again, how many mechanical mates do mate controllers support?
Okay, that was my doubt, and this is the question: how many types of mate controller accept the mechanical mates? Okay, the answer is 2. Yeah.
2?
Yeah.
No, that's wrong. I'm afraid that's a wrong answer.
4.
4?
Yeah.
No, that's also a wrong answer. So remember the slide where I showed you the different mates that the mate controller supports? And think of the mechanical mates in SolidWorks. How many mechanical mates do mate controllers support?
Someone is saying 0.
Yes, exactly, 0 mechanical mates. Because as you can see, the mate controller only supports things like distance and limit distance, angle and limit angle, width, slot, and finally the path mate. And none of these are mechanical mates. These are only standard and advanced mates. So 0 is the correct answer. So now let's go to the third question, which is, what's the maximum number of gravity forces that can be applied to a single motion study? Again, what's the maximum number of gravity forces that can be applied to a single motion study?
Okay, I start. 1.
Exactly, 1 is the correct answer. Yeah, that's perfect. So now with the fourth question, which type of motion studies rebuilds every component in the assembly on every frame? Again, which type of motion studies rebuilds every component in the assembly on every frame?
Rotary motion.
I'm sorry, I can't hear you. Can you say it again?
Is it rotary motion?
The voice isn't clear.
Okay. Is it rotary motion?
Is it what?
Rotary motion.
No, I want to know the type of motion study. There are 3 types: animation, basic motion, and motion analysis. Which type of these rebuilds every component in the assembly on every frame?
Motion analysis.
Motion analysis is a wrong answer.
Basic motion.
Basic motion is also the wrong answer, and I think we've already known that the correct answer is the 3rd and last one. It's animation. As you remember, when I showed you the animation of the ball and ratchet, where it rebuilded on every frame, that was an animation, not a motion study, and not a basic motion thing, or not motion analysis. So it was animation. I think that question, I have to get the answer to it.
Yeah.
Okay, so the 5th and last question. Okay, it's, can we change the compression of animations saved in an MP4 file format from within SolidWorks? Again, can we change the compression of animations saved in MP4 file format from within SolidWorks?
And raise करिए फिर आंसर करिए. Yes. No. आप सब गलत है. Okay. Answer is no.
The answer no is actually correct. Yes, we can't change the compression of animations saved in MP4 file format. We can only change the AVI. We can actually change MP4 using other software, but inside SolidWorks, it's not possible. So I think we are now done with the questions, and I think Amrit will now take the presentation.
Yeah. Thank you. Yeah.
Yeah, it's my pleasure.
Okay. Thank you for your concern hearing. Okay. So if you are do not have time, then you can leave here or we can continue.
Hello.